So number 9, the diagram below shows a circle with the points P, Q, R, S, a line on its circumference, and its center mark 0. RP is the diameter of the circle, and AB is a tangent to the circle at P. So P is here, APQ, 3x angle QPR, so QPR, that's up here, it's 2x, and angle RPS, so RPS is equal to x, and the angle QSP, so QSP, so Q to S to P is 54 degrees. So they give us this one angle here. Determine the value of each of the following angles, show detailed working where possible, and give the reason for your answer. Now, this is circle theorem. So we need to learn how to do circle theorem. This is way too big. That should work. So the first one they want us to find is the value of x, right, which is this here. Now, in order to find that, we need to know certain things. If this is a tangent and this is the center, this line here forms a normal. What does that mean? Is that this here is 90 degrees. So therefore, part A, part 1, right? Just making sure it's x there. So first, yes, x, right? We could say that 2x plus 3x is equal to 90 degrees. And that's because of the rule that says when a tangent, such as the circumference of a circle, from that point of intersection, which is P in this case, to the center, we form a right angle triangle. Sorry, a right angle. So that means that 3x plus 2x will be equal to 90. Right? So that means that 5x is equal to 90. So we want to find the value of x. Sorry, by dividing by 5, not x. We're going to find the value of x by dividing by 5 on both sides. So x would be equal to it's not right. 18 degrees. Right, so this value is 18 degrees. Fix it a little bit. Then moving on. Now this will give a reason why. Now circle theorem, the angle formed by the tangent, the point, the tangent, so point P and the center of the circle is 90 degrees. If I remember clearly, there's like theorem 5 or 6 or something like that. Y. So part 2, we want the angle Y. See here. Now, let's see. So sometimes you have to go back to come forward, right? So let me just make sure. Right. So this here, see if I can highlight it, is the, and it's not snapping the way I want it to snap. Right. That there is a diameter line. And any triangle formed using the diameter line forms a right angle triangle here. So if this is a right angle triangle, we could find this value here, which is 90 minus 54. 8 minus 5 is 3. So here's 36 degrees. Right? Or we could, in fact, we didn't even need to find that angle. We just know that that was 90 degrees. Right? And the sum of three angles in a triangle is equal to 180. So the angle Y will be equal to 180 minus the sum of the other two angles. So this is a 90 degree, that's 90, plus this is 18 degrees. So we can tell you what Y is. So 180 minus 108 to 72 degrees. So this here is 72 degrees. Y again, the triangle formed by the diameter line and a point on the circumference is a right angle triangle. And the second reason would be, so that would be the first reason. The second reason would be that the sum of the angles in a triangle is 180 degrees. And then we want to find Z, which is up here. Two ways we could do it. We know the value of x, so this is 18, this is 2x, which is 36. Gotta add these two to say that is the other side of the triangle. And again, sum of the angles and triangles 180, so you take away this angle and the angle here from 180 to get Z. Or you could use circle theorem to say that this angle and this angle would be equal because they are bounded by the same chord, right? So part 3, angle Z is the same as angle Y. So Z is equal to 72 degrees Y. So this line S to P is a chord and it forms a segment of the circle, and angles at the circumference this thing is not writing properly. Equal when formed using the same chord. So again, this would be the chord, and this angle, or this triangle, and this triangle are formed by the same points on the circumference more or less. So this angle here and this angle here will be equal. Then we go on to B. The diagram below shows a straight road connecting tongues. That's L, M, N, and R. LR, so L to R is 18 kilometers. L to N is 12 kilometers. M to N is 10 kilometers. Angle RLN, RLN is 25. and the angle LMN is 88, as here. And they give us a bearing from north, which is 50 degrees. Calculate the angle MLN. So MLN. So let me throw a copy of this diagram. Add a new page for that. So this will be 9B. Right, so the angle I want us to start with, MLN. So MLN, this angle here. Now, right, so let's begin. So that angle there. Just using the information one more time to make sure I don't miss anything. Right. So therefore, how we do go about doing this? Now we have two sides of a triangle. We have this side here. Right? Now we could use something called the sine rule. So label in your diagram, common L will be here, and common M will be here. So that means using the sine rule, we could come up with the formula common L over sine theta, which is this angle here, is equal to common M over sine capital M. And then we can fill it in. So common L is 10 over sine theta. We don't know what the value of theta is as yet. M is 12 sine 88. Now, we want to find this. We want to make it numerator. Right, so we could switch the positions of these here using cross multiplication and say that 10 over 12 is equal to sine theta over sine 88. Then again, we want the sine theta by itself, so we'll multiply by sine 88 to get rid of the denominator. You'll have to do it on both sides. And don't forget your sine. So this will cancel with this. We'll have sine theta is equal to sine 88 degrees by 10 over 12. Now, so my calculator, I have to press this first. Sine, you get the value of sine, it equal, then multiply by 10, then divide by 12, and we have 0.832 is equal to sine theta. Now we want to get theta, we want to get drop the sine, so we sine inverse 0.832 equal to this. So sine inverse, you have the second function. So 0.832, second function, sine, and we get 56.3. Again, this thing is not working. 56.3 degrees equals the theta. Now, I would round this off to get 56. So just checking the weekend. Yeah. 0.832, second function sine, just making sure. So part 2, they want the length of NR. Where's NR? NR is here. So they want this length. Let's call it X for now. Now, in this triangle, let me highlight this triangle, right? We have one angle on two sides, and the opposite side to the angle is what is required. So we could use something called the cosine rule. So the cosine rule. The cosine rule states that the opposite side to the angle squared, so in this case, the x squared, is equal to the square of the other two sides, the sum of the squares, so 12 squared plus 18 squared minus 2 by the product of the two sides, so 12 by 18 by cosine the angle, which in this case is 25 degrees. So we have x squared is equal, and we can work this out in the calculator in one step if you want, but I like to show you working. So we know 12 squared is 144, 18 squared is 324, and then minus. So I will do the cosine section first. So 25 cosine equal multiply by 2, multiply by 12, multiply by 18, 391.5. So we come back on your calculator and we're going to work it out now. So 144 3, 24, subtract 391.5. So we have x squared is 76.5. Now to get rid of the square sign, we need the square root. So we square root both sides. This and that will cancel out. So we get x. X is equal to square root of 76.5. 76.5 square root 8.7. So that means this value here is 8.7. Now determine the bearing of R from L. So of R from L. So basically we're going this way, which means that this is the bearing that they want. Now bearings, because we measure from north, we'll be adding these three sides or three angles here. So we know that we work this out to be 56.3. So the bearing of R from L is equal to 50 add 56.3 add 25. 3, so 131 degrees, 0.3. Now bearings are usually measured only using three values. So we'll round it off to the nearest whole, right, and put the approximation sign. That's the end of that question. All right, so question 10e. 3 points O, P, R, S are shown on the grid. O is the origin. Write the position vector. So let me draw this first. So we can see that. Write the position vector of R. OR is in the form AB. So all right, so this is R here. So this is R here. They want the position from O from O to R, position vector, right? And basically what you do is that you take the coordinate of R, which is 5, 1, and you write it as a vector. So A part 1, B 5, 1. Right? So you're not going to just write it like that. You're going to say OR is 5, 1. Right? Another point Q is located in such a way that QR so is 2 and negative 4. Using this information, plot the Q point on the graph. Now, QR means that you're going from Q to R. But in order to find where Q is, we need to minus the vector from the position R. So what does that mean? So we know that OR is 5, 1. Just so that. We know that QR is, let's make sure it's correct, 2 and negative 4. So in a vector, I would say this is R here, and let me just put Q randomly in a spot, right? We know that going this way is 5, 1, and going this way is 2, negative 4, right? So we really want to find OR. So in order to do that, right, we have to go backwards more or less. So we have to subtract, right? So we will take 5, 1 and subtract 2, negative 4, and you'll get 3, 5. So that will give us the position of, or give us the vector OQ. And how do we plot that? Just as we see it, 3 on the X and 5 on the Y. So this will be Q here. Just seeing it. Q, just 3, 5. Now, how do you know if you're correct? The vector from Q to R right, is 2, 4. We move 2 on the X, and negative 4 means that we move down on the Y. 1, 2, 3, 4. So yes, we are correct, right? So they want to plot the point on the graph, which we just did. So Q, in this case, is 3, 5. Determine the magnitude of QR. Now this dashed line here means magnitude. You write it out for you just in case. Right now, QR using the vector. So let me zoom out a little bit so we have a space. All right, so this is part 3. Right, we know QR, the vector QR is 2, 4 would be the square root of the X value squared plus the Y value squared. So 2 squared plus negative 4 squared, which is the square root of 4 plus 16, which is the square root of 8, sorry, not 18, 20. And you use your calculator to get it exact. squared, 4.47, 4.47 units, because we don't know the centimeters or what. So the magnitude of QR is 4.47 units. In other words, the magnitude is the distance between the 2 points, right? Show by calculating that OPQR is a parallelogram. So show that if we were to continue the shape, let's see if I could write in a different color. If we were to continue the shape, we'd see that this is parallel to this and this is parallel to this. Now, how do you do that? All you have to do is show that this vector is equal to this vector, and show that this vector is equal to this vector. Now, so that's part 4. We know that OR is 5, 1. So basically, we're trying to say that PQ, right? We have to show that PQ is 5, 1. So PQ is the same as saying OP minus OQ. OQ minus OP, sorry, I have in the wrong direction. OQ minus OP. Right, so the letter behind the space. Right, so the vector OQ, since we know the position of Q is 3, 5, so 3 over 5, minus, and the position of P is negative 2. I'm going to write it into the wrong color. Negative 2 and 4. So that could be written as a position vector as negative 2, 4. 4 for future reference, right? And we subtract it. 3 take away negative 2, turn out to add. So 3 over 5, and 5 minus 4 is 1. So this is PQ, which is the same as OR. So PQ is 5, 1, which is the same as OR. So we could say that PQ is equal to OR. Now we have to do the same thing for the next side of the shape. So basically, we did this part already, so I'll highlight it. We did this part here. Now we need to do this part. And we know QR, they give us QR. The vector QR is 2, negative 4. So basically, we have to show that PO is 2, negative 4. Now, PO is the same as negative OP. And OP is negative 2 over 4, which is 2 over negative 4. So we multiply negative 1 by negative 2 to get positive 2, negative 1 by 4 to get negative 4. And we can see that PO is same as 2, negative 4, which is the same as QR from here. So therefore PO is equal to QR, and therefore OPQR is a parallelogram. So what we just showed is that because the vectors are equal, meaning that they will be in the same direction and they will be the same magnitude, right? So that's proven that the vectors are parallel to each other, right? So that's that there. Right, calculate the value of x and y in the matrix equation below. So matrices. Add a new page. So this is 10p. 1, 5, 2, y. Negative 4, 1, 2, 9 is equal to x, 46, 6, 65. Now, no sign means that they're multiplying, and we usually multiply row by column, right? So let's call it row 1, row 2, column 1, column 2. So row 1 by column 1. So this position, so this position will multiply here, and this position will multiply here. Right. That's vector multiplication. So we'll have 1 by negative 4, and we added 5 by 2. And in this case, it's supposed to be equal to x. I will not go there as yet. Then we have row 1 by column 2, which is 1 by 1, add 5 by 9. Row 2, we have 2 by negative 4, add y by 2. And then we go in row 2 by column 2, which is 2 by 1, add y by 9. And again, it will be equal to x, 46, 6, 65. Now, we simplifying. 1 by negative 4 is negative 4, plus 5 by 2, which is 10. Negative 4 plus 10 is positive 6. 1 by 1 is 1, plus 5 nines are 45, so 46. And then we have 2 by negative 4, which is negative 8, plus y by 2. So we have negative 8 plus 2y here. And we have 2 by 1, which is 2, plus y by 9, which is 9y. So 2 plus 9y is equal to x, 46, 6, 65. Now, what you can see is that this and this in the same position, this and this in the same position, this and this in the same position, and this and this in the same position. So we call it equating. So therefore, positive 6 will be equal to x because they're in the same position, right? And we're using an equal sign, right? So they call them equal matrices. So this position and this position is the same. Now, what does that mean? Is that we could use either one of these two to work it out. So we could say negative 8 plus 2y is equal to 6. Carry the negative 8 across the equal sign. Should become positive. So we'll have 2y is equal to 6 add 8. 6 add 8 is 14. So we have 2y is equal to 14. Divide by 2 on both sides to get rid of the 2 here. And we'll get y is equal to 7. So we have x is equal to 6 and y is equal to 7. You don't need to work out the next one because you work it out once. Part C. So 10 part C. The transformation T is represented by the matrix. So T is 0, 1, 1, 0. Maps S is 2, 5 onto S prime, which is 5, 2. Describe fully the single transformation T. So basically, yeah, asks us to state what kind of transformation that is. Right. From matrices, this here is a reflection. No, this is from translation, sorry. transformation. So this is a reflection in the line x equal to y. So basically, if x is 2 here, right, it would be the y position in the reflection. And if y is 5 here, it will be the x value in the reflection. So there's a reflection in the x and y, x equal to y line. Sometimes a way to prove it is to draw a little graph, but because of how the question is structured, you just need to know what it is. If it was 1, 0, 0, 1, right, this is the identity matrix, and you will get back the same thing if you multiply it, right? So yeah, there's a reflection in the y equals the x line.